why the sample size calculation is essential. Here we will talk about some items that we really need to have a sample size calculations. That sample size usually denoted by n, small n. So the first thing is to be logical, because there is no one that accept any magic number. Say, I want to study of 30 participants, 100, 100, or even the whole available subjects that the researcher have. There is no such thing. Second, to be not too large or too small, because the sample size lead to the budget. The more the sample size, the higher the budget we need to conduct the study. And other thing is that we will not go for the too large, because not only the price, the cost, but also we engage too many participants unnecessarily, which is unethical. Or too small, that could lead to an inconclusive findings or no answer from that efforts. That means we engage participants to the study without any benefit. Thirdly, to justify with the sponsor or the ethics committee or the institutional review board about this required sample size is really justifiable, is really reasonable. And to ensure about the proposed sample size n have an adequate power to detect a significant finding at the end, or to have a desired precisions, for example, plus or minus what number of the parameter to be estimated. So that means ensuring about getting some answer from the research. There are two main approaches to the sample size calculations. One is about the hypothesis based, and the second is the confidence interval method based, or the parameter estimation based. For the hypothesis method, it involves the power. So there will be a parameter called z beta there, so that 1 minus beta error is the power. We will talk about the beta error at the end of this lecture. This method usually easy and widely available. It just ensures a significant findings. That means p-value is expected to be less than 0.05. But it may not be conclusively meaningful, because p-value depends on the large or the small of the sample size, not the effects of the size. But usually we will base the conclusions on the effects of the size we study. So be careful about this method. The second method is straightforward to the conclusions about confidence interval. It involves the precisions of the parameters being estimated. That means ensure the confidence interval lies that is not cover the null value or the unmeaningful value. So it will lead to that conclusions directly. But it is difficult. The formula is not widely available. This method is ensuring a conclusive findings clinically, biologically, sociologically, because it is directly estimated the magnitude of effect that will be used as the basis for the conclusion. So this one is most preferable. Steps for sample size calculation. First, identify type of the primary outcome. Second, identify the main magnitude of effect to be used as the basis for the conclusions of the research by reviewing about size of the effect and its variations. So we will try best evidence to get this to be used for that calculation. Third, identify statistical method to be used to estimating the main effect of this research. As I mentioned in the previous slide. Then calculate the initial sample size n based on that formula. So there are hundreds of ways to calculate for the sample size based on statistical method. And then account for the design effect by increasing the sample size to account for that for correlated outcome. So this is how the issues of dependency among observations or correlated outcome involve the sample size, or the design involve the sample size calculation. We cannot avoid the roles of the design, called design effect. After that, contingency means increase the sample size to account for non-response or dropout. So there are methods to handle about this one. Then cosmetic means rounding up the sample size to a nearest and comfortable number, because this will then be used for estimating the budget of the study. In case that the final sample size was calculated based on the hypothesis testing, the formula involves the z beta. We need to evaluate it if it would provide a precise estimate that ensure to obtain a conclusive answer to the research question. Okay, how? First, try to use a statistical package, calculate for a simple confidence interval, 95% confidence interval of the main parameter based on the final n that we obtain in this step, and use the most conservative scenarios that would be expected in our settings. For example, the size of the effect, like what is the mean weight in the two groups, especially in the control groups, that would be what is the standard deviations of the weight, for example, and use the most conservative scenarios means that whatever that affect the sample size, for example, the standard deviation, we will use the one that will lead to the largest n, which is the largest standard deviations that would be in our settings. That's mean most conservative scenarios, or the difference between the two groups that expected to obtain. So the largest one will lead to the smallest one. So we will the most conservative in that case means we use the smallest difference, but still meaningful clinically. vary the important parameters that I have mentioned one at a time to see the sample size. So we have list of sample size in all possible sets of parameters in combination, and then recalculate the sample size in that original formula again. Select the smallest n, which based on the most conservative scenarios that would be expected in our settings and would lead to a conclusive findings and remain feasible. Choose that one and justify it by describing in method sections of the research protocol how the sample size was calculated with sufficient details that allows people to be replicate the calculations or verifications. I emphasize again about the approaches that for unknown parameters in the formula of sample size calculation, trying to find existing evidence. I mean, search for the literature and see what is the effect that could possibly be and found in other literatures, and what is the standard deviations or the variations in other cases of the outcome. If not available, use your best estimate, mean guess something that is best, or somebody say educated guess, you see. If you don't know, one of the very angry response is, don't do a research. Okay, so we should have some idea about what is the size and variations of our main parameters, main outcome. Do not use only one scenarios or based on only one reference for the calculation. You know, for example, if we found a paper similar to our projects and say the standard deviation is about 4.7, many people use 4.7 in the calculations. It is not a constant number actually, because it will be vary even in their settings. They repeat it again, it will not 4.7 for sure. You know, and even a lot different what would expected in our settings, it is not there. So always vary to possible value of the parameters to see how these parameters affect on the sample size calculation. So usually we will have a long table that varies parameters, not only one formula and one set of the scenarios and calculate. No. It is highly recommended the sample size should be calculated based on the methods about parameter estimations. But as I said, it's quite difficult and not widely available. So if you cannot do that, you can, based on the hypothesis testing, but evaluate its sufficiency by estimating the main magnitude of effect and its confidence interval, and see if it could provide a conclusive finding or not. If not, you can calculate again using another set of combinations of the parameters in the formula. So that's suggestion. Or, this is my bottom line, consult with statistician early. In many cases, people come to me to ask for help about helping justify the institutional review board or ethics committee. You know, it's too late already, or even worse, justify the journal reviewer that the paper is submitted already, it's too late. Usually it's not possible. Sample size calculation is the planning. Common pitfalls. Okay, the first one, not provide the paper or a research protocol did not provide any justification, any sample size in the planning. They just give some magic number and saying that there is no prior information which be based them. So they just not mention about that. So this is totally wrong. Provide the sample size but unjustified by saying a magic number such as 30. This is one of the common number. Very strange. But this number is wrong. Some saying take half of the population, what they have, or take all the patients that they have at hand, for example, is not advisable. No justification at all. Another common pitfall, like based on a simplified formula, the one that being proposed by some methodologists, that they simplify the original one to be very simple, but it's highly misleading because there is no number to allow for some uncommon settings. Usually the simplified formula are for common settings. I don't want to mention about those methods, but try to be original one. Another common pitfall is me too, saying something like this. A previous study in this area recruited 50 subjects and found to be highly significant results, and therefore a similar sample size should be sufficient, means that have 50. Never do this. We cannot rely on what is done in that setting, and if so, what you're going to do is end up with something not new. Why we will repeat something that has been done already? It's illogical at all. Inconsistent with the protocol, from the outcome of this type, but end up with something different, that inconsistent. And too much rely on the previous findings as if it is a Bible. No, you need to vary it because this is our settings, not them. Okay, these are common pitfalls for the sample size calculations that I came across in my career as a statistician.